Okay, in this video we're doing Calc AB problem set 77. The problems and a playlist are in the description below, and let's do it. Alright, find and classify the critical points of f of x equals the quantity 2x minus 1 cubed times the quantity 3x plus 5 squared. So we're going to have to find the derivative. It's a product rule, but within the product rule we're going to have to use the chain rule a bunch. So let's see how this goes. So it's going to be first, so we got 2x minus 1 cubed. Derivative of the second, there's a 3 from the chain rule and a 2 from the power rule, so 6. And then second, derivative of the first, we're going to have a 2 and a 3. So a 2 from the chain rule, a 3 from the power rule. So that's where that 6 is coming from. So if you look at this thing, there's a 6 in both of them. There's a 2x minus 1 squared, and there's a 3x plus 5. So we're going to take out 6, 2x minus 1 squared, and 3x plus 5, and see what we're left with. So I won't make you watch me do that, but we're left with essentially the quantity 2x minus 1 plus 3x plus 5. Then we want to clean that up, right? Because you have to clean everything up to find the critical points, or you're going to miss one of the critical points. So now we're going to do a sign chart, and our sign chart is for f prime, so we want to label that. We have to put 1/2, negative 5/3, and negative 4/5 on this, and we have to put them in order. So negative 5/3 comes first, then negative 4/5, and then 1/2. Now we have to test the regions. So if we test negative 1 billion, we're going to get 6, which is positive, something squared is positive, and then a negative and a negative. 2 negatives means positive. And then what I usually do is I look at the degree for the factor. So negative 5/3 comes from 3x plus 5 to the first. That's odd. 1 is odd. So you're going to have a sign change. Negative 4/5 comes from 5x plus 4 to the first. 1 is odd, so you're going to have a sign change. So we're at plus. 1/2 comes from 2x minus 1 squared, which 2 is even, no sign change, so you're going to stay positive. You can also just check, like plug in 1 billion, you definitely get positive. So we are supposed to find and classify the critical points. I never expressly said what the critical points are, so I'm going to do that. Critical points, negative 5/3, negative 4/5, 1/2. Now we need to classify them. So at negative 5/3, f prime goes positive to negative, which means you are at a relative maximum. So let's write that down. So f of x has relative maximum at x equals negative 5/3 because f prime changes positive to negative there. And then at x equals negative 4/5, f prime changes negative to positive. That's going to be a relative minimum. So let's write that one down. So we have our relative minimum negative 4/5 because f prime changes negative to positive. At x equals 1/2, you do not have a sign change in the first derivative. So although it is a critical point, it's not a relative max or min, so we don't really say anything about it. All right, next problem. Evaluate the integral of x times the quantity x plus 2 squared. Okay, so I'm going to first do this. If you've been doing all the problem sets, you've seen problems like this before. I'm going to first do this by just letting u equal the thing in parentheses, so x plus 2. And what this does is it kind of like transforms the integral into an easier integral to do. It's not a problem, but the difference is the answer will look very weird compared to the answer you'd get if you expanded first. I'm going to go back and do it that way also, so you'll see both. In this case, du is dx. And also I need to substitute for x, so x is going to be u minus 2. Just subtract 2 from both sides of that equation. All right, so when we do our substitutions, x becomes u minus 2. X plus 2 is u, so we have u squared, and then dx is du. So we have this. I will expand this to get u cubed minus 2u squared, and then du. We're reversing the power rule, so plus 1 times the reciprocal, like so, plus c at this point. And then u is equal to x plus 2. So we're going to replace every u that we see with an x plus 2. And you can see that this is the answer, but it's a little weird looking, like it's not expanded. This would be hard to work with if we needed to work with it. Another way of doing this problem is to just expand from the beginning. So we can go back and I'm going to square x plus 2 squared is x squared plus 4x plus 4. So I will do this, and then I will distribute, and then I will reverse the power rule, which gives me 1/4 x to the 4th plus 4/3 x cubed plus 2x squared plus c. These are equivalent where c is a different value for each of them. So if you check it on a calculator and just put them in and say, like, ignore the c's and say, are they equal? It'll say false because they're not actually equal. There's like a constant term on that orange one that isn't showing up for the green one, but plus c accounts for that. So different approaches give the same result, bearing in mind that plus c, could be any constant. All right, new problem. Find k so that the function Find k so that the function is continuous at x equals 4 given f of x is, so it's piecewise, it's the square root of x minus 2 all over x minus 4 when x is not 4, and then k when x is 4. All right, so we need the limit to exist, the function to exist, the limit to equal the value of the function. So in this case, the real issue is figure out the limit at 4 and then define k to be that limit, and you will have guaranteed that the limit equals the value of the function. So that's our goal. So I need the limit as x approaches 4 of f of x. So if you're approaching 4, you use the part where you're not at 4. So that's going to be the limit as x approaches 4 of the square root of x minus 2 all over x minus 4. You can either rationalize the numerator, but my preference is to factor the denominator. It doesn't make a difference as long as you do it correctly. I'm going to factor the denominator into the square root of x plus 2 times the square root of x minus 2, which gives us this. And then you can see the square root of x minus 2's cancel. So now we just have this, the limit as x approaches 4 of 1 over the square root of x plus 2. Now I'm going to let x equal 4 because I can do that without a problem. Square root of 4 is 2, so I get 1 over 2 plus 2, which is 1/4. So if I allow k to be 1/4, this thing is definitely continuous. But then you kind of ask yourself, like, did I prove that it's continuous? I mean, I think I kind of did, but maybe not. And in that case, I would go back and just say, if k equals 1/4, the limit as x approaches 4 of f of x equals f of 4 equals 1/4, therefore f of x is continuous. So that's our value of k that makes us continuous. Let's take a look at one more problem here. All right, we want to evaluate the limit as h approaches 0. As soon as you see that, you're like, that's the definition of the derivative. I just need to figure out what the function is and then take its derivative. The limit as h approaches 0, arctan of 3 times the quantity x plus h. So there's your x plus h. So from that, you could work out the function, but its limit is h approaches 0 of f of x plus h minus f of x. So f of x is going to be the next thing I read, arctan of 3x. So f of x is the arctan of 3x. So I need to find the derivative of that. So that's going to be 1 over 1 plus u squared times the derivative of u. U is equal to 3x, so the derivative of u is 3, and then u squared is going to be 9x squared. So we're going to write f prime is 3 over 1 plus 9x squared. And that's our derivative. So I guess, I don't know, I'm never sure like how to connect that work to the answer. So if you go back up and just say equals the limit, like you definitely did it. And remember, we got that from this. This is essential knowledge. This is like almost first day of class type knowledge. So hopefully you've really internalized it at this point. Anyway, that's the entire problem set. I hope this was helpful and good luck.